Hi, my name is Scott Morrison. I'm a software architect at Autodesk. I work in the developer enablement group. In our group, we are responsible for two different developer portals that we've created at Autodesk. One external developer portal that documents all of our cloud APIs and has market information about our API offerings, and a brand new internal developer portal that we just rolled out an MVP release for that about 2 months ago, and it's based on the Backstage framework. So today I'm going to talk a little bit about how we publish documentation for our technical documentation at Autodesk using the Docs as Code approach. And I'll talk a little bit about how we can unify our documentation pipeline that will work for both our internal and our external developer portal, and some of the problems and challenges we have with our pipeline and how we'd like to improve those. And then I'm going to do a little bit of a demo demonstrating our documentation pipeline running locally on my laptop. So we use the Docs as Code approach for our technical documentation at Autodesk, and it's used quite extensively. We've been doing this for about 6 or 7 years now, and we have a fairly mature documentation pipeline to support this. The Docs as Code approach has become industry standard for publishing technical documentation. The basic way Docs as Code works is that you store all the source for your documentation in GitHub, and usually in a text-based format. In our documentation pipeline, we support both Markdown and restructured text as input formats, but we also support a lot of other formats for generating reference documentation. So, for example, we can take an open API file and build the technical or the reference documentation for that based on the open API file. And that gets integrated with the rest of the handwritten documentation that includes things like an introduction to the API and step-by-step tutorials and those sorts of things. We do that frequently for all of our REST APIs, but we also support automatic reference documentation generation for some SDK types in various languages. We have support for JavaScript and TypeScript documentation, which is the format we use the most on our developer portals today. But we're also expanding that functionality. We're working on right now support for GraphQL schemas, so you can just reference a GraphQL schema file, and we'll automatically generate the reference documentation for that GraphQL API. And we're also working on adding support for other languages. We're going to be supporting SDKs in languages like C#. Eventually, for our desktop products, we'll probably be also supporting C++ and several other languages, Python. We have a lot of different programming systems at Autodesk, and we eventually want to support all of those systems for automatically generating reference documentation in our documentation pipeline. So we also have, as part of our pipeline, a few utilities that help out in developing documentation and APIs. One is that we have an API linter. An API linter checks an open API file and makes sure that it conforms to the Autodesk REST API standards. So we have a bunch of standards about how to do naming of endpoints and parameters and things like how to do pagination, and this API linter will point out problems, and that runs part of your build pipeline that also builds documentation, so you can find out if your open API file is conforms to our standards at the same time you're building our documentation. We also have support for runnable sample code, which we use in a few places. For our sample code, we can reference external files, and the external files can be part of our CI/CD testing pipeline, so that we make sure that all the code samples, or this isn't used for all of our samples yet today, but we're using for some of them, the sample code actually runs and is up to date. We also have some support for dynamic content. We do that with HTML embedded in the Markdown or RST file. The screenshot here on this slide shows an example of that. One of our most popular facilities for the Autodesk Platform Services that our team supports is a viewer. It's a 3D viewer that you can embed into a web browser, and this has been proven to be a very popular component. Most of our developers who are building applications based on our APIs somehow use the viewer as part of their workflow. And we have a dynamic example. In this case, we're using CodePen, so you can embed an actual 3D viewer in your documentation and play around with the HTML and the JavaScript that are required to drive that viewer in the browser. It makes it very easy, nice interactive experience to learn about all the features of our 3D viewer. We also support ways of mixing handwritten menus and generated menus, because as I mentioned before in the previous slide, we generate reference documentation automatically from various formats, and the menu for those that reference documentation needs to be injected into the handwritten menu for all of the other documentation, like the tutorials and so forth. We're expanding the use of this pipeline to go beyond just our cloud APIs, which is what it's mostly used for today on our external developer portal. But we're working on unifying our developer documentation support to also include desktop products. So eventually, we're going to be using this in a unified developer portal for both all of our cloud and desktop APIs. And Autodesk has a lot of desktop APIs. It's the company is known for its desktop design applications like AutoCAD and Revit, and those have been desktop platforms for many years. And they all have their own separate documentation. Today, they're spread out over different sites and different formats, and eventually we want to unify that so that we have all our documentation in the same format on the same site, and they'll all be using these same Docs as Code tools that we have. This is something that we're doing incrementally. Today, we have a site that is sort of an index or a link farm to all the documentation, but eventually we want to have it all hosted using this new documentation pipeline. So this is all done with custom work. We have a custom doc pipeline that we've been developing for about 4 or 5 years now. Previously we had another documentation pipeline, but we replaced that a few years ago. This is something that runs on our CI/CD servers, which is Jenkins we use at Autodesk. And its main job is to take the documentation source, the handwritten things in Markdown and RST and so forth, and also the reference documentation, and it compiles it into HTML. And one thing that's convenient in our pipeline is that when we do a pull request that changes documentation in GitHub, we automatically generate a preview build. You can see that in this screenshot over here. It's maybe a little hard to see, but there's a link to a preview build that when you link on this, it'll actually bring up the documentation as it will look in our developer portal, sort of in context of the developer portal. So this is the way that writers, when they change their documentation, they actually can review it in the developer portal as it will look, as opposed to just writing like raw HTML or RST on their desktop machines or their laptops. It would be you can't preview it as it looks in context. So you can see what the content looks like, but the styling and all the rest of the menus and things would be different. But this is the way to see the documentation as it will appear to our end users. And once we produced all this HTML, we put it into a zip file, and we put it into an artifact server that we use JFrog's Artifactory for our artifact server. And then we automatically publish that documentation in our development environment. We support 3 different environments for our external developer portal. We have development and staging environments that are just available internally in Autodesk that we use for testing, and then we have a production environment where our customers actually see the documentation. So when you first do a documentation build, we automatically deploy it to our development environment, and then we use an interface called Spinnaker, which we also use to deploy our software, our cloud software at Autodesk. And you can use Spinnaker to promote it once you're happy to the staging and eventually to the production environments. But the documentation will look exactly the same in all the environments. It just redeploys the HTML and that zip file into different S3 buckets that are used for those different environments. The last thing we have here is in order to make this all easy, we have a custom GitHub application that you can attach to your repository. It will automatically invoke the pipeline. So rather than setting up webhooks in GitHub and so forth to invoke a Jenkins server, all of that is automated for you. All you need to do is set up a configuration file and attach this GitHub application, and it'll invoke the documentation pipeline for you automatically. This is just a brief architecture diagram that shows one part of our pipeline. This is mainly talking about the part of our pipeline that will translate an open API file into HTML. We have a custom written application that we've had for many years called Swagger to Forge, which is used for taking an open API file and compiling it into RST Then we have another application that will take the restructured text files, and it's called DocGrunt, and it compiles it into HTML. This is all driven by a configuration file, which is a little bit hard to read on the left there, but we have many configuration options, maybe too many. I'll talk about that in a minute. And once that documentation is all built, we put that HTML into Artifactory and then start deploying it to the various environments. As I mentioned, we've also implemented just very recently a new internal developer portal, and the internal developer portal is based on the Backstage framework. Now, Backstage comes with its own documentation system called TechDocs, which also uses the Docs as Code approach, but it's based on a different system. It's based on the MKDocs or MakeDocs technology, and it doesn't support all the features that I mentioned before. It definitely supports Markdown out of the box, but if you want any other types of documentation, like our reference documentation for Open API, you need to start using plugins for MKDocs, and it's not going to be compatible. It won't look the same as the documentation we get out of our pipeline that we have for our external developer portal. So we decided we wanted to try using the same documentation pipeline for both the internal and the external developer portal, and we've started doing some prototyping work to see if that is practical. And one of the nice benefits of this is that if you're developing a new API inside Autodesk, but you plan on making it public, you can do all the documentation on the internal developer portal. It supports all the same documentation types as our external portal, and it'll look exactly the same, format the same, style it the same. So you can be assured of what your documentation looks like. And then when you're happy, or when it's about to be released to customers, you can just promote it to the external developer portal, and those exact same documentation will be promoted and visible in our external developer portal using all the same HTML and CSS. It should look exactly the same. So here's an early prototype of that. It doesn't implement everything I just mentioned, but yeah, right here on the left-hand side of the screen, you'll see a documentation for an SDK that we have that's on our external developer portal. This is an authentication SDK for our browser. And then on the right, you can see that it's the same documentation content. This is shown in Backstage on our internal developer portal using the TechDocs system. And you'll notice it doesn't quite match in style. The content is exactly the same, but if the colors and fonts and so forth don't quite match yet. So we're still early in the process. Eventually, we want to make it so everything matches up exactly. So in order to get this to work in Backstage, we'll need to customize the TechDocs plugin. So out of the box, TechDocs does its own kind of formatting, uses MKDocs to generate the HTML. But we want to instead use TechDocs as the renderer, but use our own documentation pipeline to create the HTML. And there are a few things that need to change for that. We have a different menu format than MKDocs uses, and we want the HTML to come out of the same place, but how we actually form the menu, the navigation menus that you see on the left-hand side of the screen when you're looking at our documentation is a little bit different. So TechDocs needs to know how to read that different menu format, but the actual HTML is stored in the same kind of S3 bucket that is used for the normal TechDocs system. The main difference is how the menu is actually read, but otherwise it's using TechDocs system, and you get all the features of TechDocs, and you can search documents and all the things you can do from the Backstage TechDocs system. As I said, this is a very early prototype. We're not in production with this. We just came online with our internal developer portal a couple of months ago, but this is ongoing work that we want to do to support both of the internal and the external developer portal. So we have had that our current pipeline for a while. Then there are some issues with it. In the code, it has a large dependency on running on this Jenkins system, our build servers. And Jenkins uses a language called GroovyScript to implement all of its actions, and that basically can't be run on your local machine. So we have a problem with our current pipeline that it really only runs in the cloud running on Jenkins server. If a writer wants to see their documentation in context, they have to make a pull request, and then that pull request has a link to that preview build that I was showing you before. But that can be a slow process. Jenkins servers can sometimes take a while to spin up, depending if there's resource contention for them. So it can be, on the order of minutes or half an hour or so before, just to see a preview of what your documentation looks like. So we'd like to have a pipeline that deals with that better. Our onboarding is it can be simple. The people who've used the documentation pipeline for a while are able to onboard quickly, but the first time it can be challenging. We have a lot of options in our configuration file. It makes it a little bit tricky to know exactly how to configure it. We like to be able to simplify that. MKDocs is a great model. The one that's used in Backstage has a much simpler onboarding process. We also have the problem that the business logic that runs the pipeline is spread out across many GitHub repositories, some for the code that runs in Jenkins, some for some Docker images that do the actual translation. Then there's another Docker image that does the HTML translation to HTML, and all these get put together, but the code is also separate GitHub repositories, and it can be quite challenging for the developers on the system to know where to go to actually make any kind of a new change or change to the documentation pipeline. Another thing that I consider kind of a challenge is that we use a custom support for our open API. So we don't use any of the off-the-shelf or open source components like Swagger UI or something more proprietary like Redocly to create our reference documentation. We have our own custom application, and that presents some challenges because we constantly have to be updating it, both for changes to the open API format or just things in the open API format that were not 100% supported. So it's a constant challenge to keep that application up to date. I would much prefer to go to off-the-shelf tools for that sort of thing. So we want to re-architect our pipeline. One of the main goals is that it can run 100% locally, so that writers, when they're working on their documentation, can immediately compile into HTML and see what the results look like on their own local laptop without having to make a submission to GitHub to see what the documentation looks like. We want to make a pluggable system for our translators to make it easy to run to add new documentation types. So each one of these translators will live in a Docker container. We want to make it really easy for writers to set up. So we have a prototype of this that I'll be showing in a few minutes, that writers can run these scripts that will automatically install the documentation pipeline locally, and then make it easy to watch for changes in files and have the documentation updated in their browser automatically. We have in order to do that, for this prototype that I'm going to show, we have a sort of a customized viewer that runs in the browser, and it knows how to get the documentation locally from the local file system rather than normally it's grabbing it from an S3 bucket. And it can support live updates for sort of a not quite what you see is what you get workflow, but it's very close. You can get very quick previews. Now I'm going to give a little demo of that system. Okay. Actually, I want to go to Visual Studio Code. So here I'm in Visual Studio Code. This is a source for a documentation site. This is a restructured text file, and I'll show you what this looks like in our system. Oh, hold on. I got to start up our pipeline. I'm sorry. So I'm going to start the local documentation pipeline here. So what this is doing is it's spinning up a bunch of Docker containers that have all the translators and all the support for translating documentation into HTML, and then supporting a local file system to actually preview the documentation. And then in another window, I'm going to start up another process that sort of watches a directory. It says, look, I'm currently working on files in this directory, and I want to watch for any changes to those files so that it'll automatically rebuild the HTML and be able to preview it very quickly. So now, hopefully, this is now set. There we go. Okay, so here's a sample page. Now, this is not particularly an interesting page, and I'm going to do a very simple edit on it just to show that this actually works. Nothing complicated. This is some sample documentation, and it's actually got a typo in it. So instead of this is supposed to say pipeline, it says pipline. So I'm going to go into the source of this documentation. That is done right here where it says pipline. And so I'm going to fix that. So it says pipeline, and I'll save the file. And you'll notice down in the console window down here, it actually did something. It noticed that file changed. It re-implemented or retranslated it into HTML. And now if I go back to the browser and reload this window, you'll see that it's changed to pipeline. Now this doesn't seem very, this is a very simple example, but this is something that in our previous system would have taken about, 15 minutes to do. So you'd have to go make a pull request in GitHub, and there's a lot of there's a lot of work around that. And this way, you can just write your documentation, see what it looks like on the local developer portal, and it happens very quickly. And then when you're happy with how it looks in your local preview, then you can make your pull request and not have to do that every time you just want to see what your documentation looks like. So that is the example of our pipeline running locally. It's the first step in doing this unified pipeline. And that is the end of my presentation. Thank you very much.